Good morning, professors. I welcome you all for the final day of FDTP session 1. We have our resource person here. So, Dr. Kannimuthu S. Welcome, sir.
Thank you. Thank you.
So, Dr. Kannimuthu S. is currently working as a professor in Department of Information Technology, Kattam College of Engineering. He has a total of 16 years of experience in teaching and 1 year of industrial knowledge. And his areas of interest are artificial intelligence, machine learning, data structures and algorithm design, big data analytics. He's serving as mentor for deep learning AI USA and also a data science consultant. His professional achievements include IBM cybersecurity analyst, deep learning.ai TensorFlow developer, SAS programmer, SAS visual business analytics. He has completed more than 600 online certification courses in Coursera, 41 specialization courses, and 4 professional certifications. He has hacker certifications in Java, Python, SQL, and problem solving. He has published more than 4 patents and has received funds from ISRO, CSIR, DRDO to organize various workshops and seminars. He has delivered more than 127 guest lectures at various institutions. He has published more than 53 research articles, which include 29 in Scopus and 18 in SCI. He has presented in more than 10 conferences, written book chapters, and acted as chairperson for more than 18 conferences. I welcome you, sir.
Thank you, Ante.
The session is all yours, sir. You can start your session.
Okay. Thank you. I think you are able to see my screen.
Yes, sir.
Yeah. Good morning, everyone. This is Kannimuthu from KCG. Today, I wish to present session in hashing technique. First of all, I thank the management of our institution, Anna University, and the HOD of CSE faculty members for providing this wonderful opportunity to present session in data structures. So, I think previous session you came across variety of data structures like array, linked list, stack, queue, and algorithms such as sorting. Today, I'm in a position to present session in hashing technique. Like other data structures, hashing is also a ADT. For example, the main use of hashing technique is to perform basic operations such as sort, insertion, deletion, and searching in constant running time. So there are two basic data structures which paves the way to store the data in a memory, such as array and linked list. With the help of array and linked list, we can define and create a hashing ADT. So why hashing? Hashing is mainly used for store the data and retrieve the information as quickly as possible. If wish to store data or retrieve the data or search the data in constant running time means we can prefer hashing ADT. From the name itself, I can say the hashing involves hash function. There is hash function is a mathematical function which involves modulo operations or some kind of mathematical operations which accept variable length of input and returns the fixed length values. So hash function, hashing technique involve hash function. If we use a hashing technique means we can reduce the running time, that is average case running time and the best case running time to constant times complexity. While you're performing insertion, deletion, and searching. But the worst case complexity is still order of n, but it gives order of 1 running time complexity in terms of average. or best case. Many data structures yields order of one running time in the best case. But if it's to have order of one or constant running time on average, means we can go for async technique. But in some situation, we compromise memory complexity. That is, if we use async technique, means it occupies or it consumes memory, which is linear. That is order of n. Okay. So hash function, hashing technique or hashing ADT involves hash table. So we can create a hash table with the help of array or linked list. If you use array, means the memory will be allocated in a continuous fashion. If you use linked list, means the memory will be allocated in random manner. There are basic operations which is pertaining to hash table. Those are all creating the hash table by using array or linked list. Okay, as your base. Otherwise, we can perform some important operations, significant operations called searching, insertion, deletion, and deleting the hash table. Searching is used to find the key which is available in the hash table, and insertion operations is used to insert a key into the hash table one by one. Delete operations is used to delete a key from the hash table. Deleting hash table involves deleting the hash table entries in a memory. So these are the operations that we used to see. So if we use linked list means, okay, so the hash table will be looking like this. So the hash table will be the array of linked list. Initially, it is set as null if no entry is available in the hash table. For example, if I prefer linked list means you can use array of linked list to store the data. The keys are stored one by one. Consider I take hash table size as 6. So the array index from 0, 1, 2, 3. It is array of linked list index from 0 to 5. Initially, it is set as null. If I wish to store the data into the hash table, means we can use linked list or array. Here I prefer linked list. If I wish to store value 5, means so I can use hash function for this. So the hash function is defined as h of x. Here x is a key, h is the mathematical function, hash function. I just mention x modulo, or you can use percentage symbol modulo. The hash table size I have considered 6. No, just mention 6. Okay. Now I used to map the key to a table. So I use h of 5. Just use h of 5 equal to just submit the value. Apply the values. You will get 5 modulo, which leads to 5. So in fifth position, I create a new node, just to field. Here can set the next field as null if it use linked list, and just to store the value 5. Okay, if you wish to store the data to 21 means just apply hash values 21 modulo 6, but you will get 3. That 3 value is mapped by creating the data 21, and it just set us. What happens if the hashed value which returns the same value means you have to create a new node. That's all. For example, I wish to or 10, no, 12. It's not possible. Okay, I just store this value 17. Just apply 17 modulo 6, but you will get 5, no? So already you have uh, some data in the fifth position. Again, the same values mapped. In this situation, just to create a node, the next page and set as null, and associate this node with this node by keeping the address of this node to here. For example, address of newly inserted data 17 is 1000 means just to store 1000. This way we can use linked list to create a hash table and store the data into the hash table. It's a memory, it's kind of memory, but it is the way in which you are accessing the data is linear, but memory allocation is non-linear. Okay, so in this way we can construct a hash table. If you wish to search the data into the uh, hash table or delete the data from the table means the beauty of hash function is you can use same hash. If you use any other method, for example, other data structures called stack, queue, linked list means insertion, deletion, such procedures seems to be different, which uses different methodologies. If you use hash table means for all the operations, you use hash table, that is, you use hash function to perform the same operation. That is different operations like insertion, deletion, insertion. So the core or heart of hash table operation is hash function. So I wish to discuss the types of hash function here. So there are 4 kinds of hash functions. One is division method, which we investigated already now, and there are other methods called multiplication method, mid square method, and the folding method. We can use either one of these techniques. First, I have already explained about that is division method. The same thing is mentioned here. It is h of key equal to key modulo size. Size means size of a hash table. Here, I just consider hash table size as 20, and the key, that is data to be inserted or searched or deleted, is 91. Just apply hash function, that is division method. You get 11. That is 91 modulo 20. You will get 11. So in the 11th place, if hash table size is 20, 11th place, I can store the data. Okay, this is the division. It's a very easy method, most commonly used method. And I wish to tell about the next method called multiplication method. In multiplication method, we have a 4-step process. First thing you have to do is you have to choose a constant which is in the range between 0 and 1. Okay, and multiply that key value. There is what value that is to be stored in a memory as table is to be multiplied by a constant, that is a. After multiplication, just extract the fractional part of a and a. That is, you will get k and a after multiplying the key value k and a. Just to take the fractional part. Then multiply the fractional part by the hash table size and take the floor value of the multiplication. Floor value means the smaller, the largest number, which is less than the particular number. Okay. So the floor value of the multiplication may be received. Okay. By using the value, you can store the data. Here I wish to explain with an example. Here I have the search key as, the element to be inserted is 1 and hash table size is 8. According to the procedure, I have taken the A value as 0.61. I need to choose the value that is number between 0 and 1. So I have taken 0.61, and which is to be multiplied by the key that is to be inserted. This 1 into 0.61, you will get 0.61. Now, this 0.61 is multiplied by the hash table size. You will get 4.8. If you take, according to the fourth step, if you take the floor value of the multiplication, you will get 4. That is largest number, which is less than the 4.8 is 4. Largest whole number, which is less than the 4.8 is 4. So I can store the data that is key 1 in the fourth place. This is the concept behind multiplication method. Next, I wish to tell about mid-square method. In mid-square method, what you do is we can use this kind of method if the key is of big size. Okay. For example, if you have a key as 9452 means, just square it with the help of power function. Okay. You will get some large digits now. From that, just take the middle value, that is mid-square value. Okay, just to take a key and multiply by same number, and you will get some result. No, just take middle value. So the option, the middle value should be a small size, that is which is less than the hash table size. So you have to take the values which is less than the hash table size. So the address is 3403. Okay. So this kind of value is stored if the hash table size is ranging from 0 to 9,000 triple nine. So you have to take the value in such a way that which leads to which is less than the double and double nine. Okay. So if your hash table size is 2-digit, mean just take middle two values. Okay, that is up to you. That is you have to choose the values which is less than the hash table size. So be careful while while selecting the mid value, mid squared value. Okay. Next method is folding method. Folding method. What you do is here just take the key. If key is very large, we can go for folding method. In folding method, just divide the numbers, there is keys, into equal parts and perform addition operations on the key, that is the splitted key. You will get some value. No? I get 1368. If I add 3 watt, you will get some values, that is 4-digit values. If according to the hash table size, we can eliminate the MSB part. Here, my hash table size is 3-digit only, so I take the last 3-digit, and this is considered to be the memory address of the hash table. In a similar way, if we use fold boundary method, means we can split the digit and reverse the digits. You will get some value. You know? That value, according to the table size, we can discard one or more digits and take the some part, take some digits and make it as a hash table memory address. So this is the folding method. Folding method can be of two types: fold receipt and fold boundary. In fold receipt, what we do is we just divide the data and perform the addition operation. In fold boundary, you divide the data and digits are reversed, then you perform the addition operation. Then finally, you are getting the digit part, address part to map the key to the value. Okay, so this is the one kind of method in hash function. So I have discussed about these types of hash function. If you have any issues in understanding it, you can tell me. Do you have any queries in that? So I hope so. You don't have any issues in understanding. Next, I wish to tell about some important methods that is to be used while you face collision. For example, if I wish to perform hashing operation, for example, if I wish to perform hashing operation by using array, I consider the hash table size as 5. Consider m equal to 5. So, dimension 0, 1, 2, 3. So I make use of array for storing the data. Consider this. Now I wish to use division method for storing the data. For example, I wish to store 6 by using division method. So use 6 on row as table size is 5. What you will get is 1. Just store 6 here. Now I wish to store some other data, for example, 9. So just perform modulo operation. I will get 4. So 9 is stored here. Now I wish to store 14. What will I get? 14 modulo 14 modulo 5. What I get? 4. Okay. So when you divide 14 by 5 means you will get the remainder as 4. Now this 4 value is mapped to the table, but I supposed to store 14 in the 4th position, but the data is already available. That is, the memory location is not free. Now I'm not able to store the value 14. There is new value 14 to the table. This situation is called collision. To avoid collisions, I use several methodologies. Okay. So that I wish to discuss now. So if the key is mapped to the memory table, there is more than one key is mapped to the same entries means the collision arises. The collision can be avoided by using the collision resolution techniques. Okay. Now, how the collision happens? This is illustration illustrated in animation. Just see here. So initially, I store some data 26, 40 is stored, 55 is stored, 23 is stored. Now, 20, again, I wish to store 25. When I apply 25 modulo 10, the I will get 5, but in 5th person already 55 is there. I can't be able to store 25 here. So this situation is called collision. To avoid collision, I may use a collision resolution technique. Okay. So maybe you may take some decision to store the data next to freely available locations or some other locations based on some strategies. So here I'm in a position to tell about probing. What is probing? There is a keyboard that is supposed to use in hashing methods. It's called probing. Probing means attempting to store the data in a hash table. Attempting to store the data in a table. So if you while using hashing technique, you try to reduce the probing. There is number of probe. If number of probe is 1 means you feel very happy. If probe gets increased means okay, the running time may leads to high. So you may not achieve order of 1 running time if your probing sequence is high. So try to avoid, that is try to reduce the probing. Okay, good. Next, I wish to tell about collision resolution technique. So collision occurs actually when the hash function maps two different keys to the same memory location. Okay. To avoid this, there are two most popular methods of resolving collisions are available. Okay. First one is closed addressing. Second one is open addressing. In closed addressing, we use linked list concept, that is array of linked list concept to manage collision. In open addressing, we use three kinds of method. Basically, if we use array for implementing the hash table, means we can use open addressing technique. There are three kinds of open addressing collision resolution technique. One is linear probing, second is quadratic probing, and the third one is double hash. Okay, these are the collision resolution techniques. So you must be able to differentiate the types of hash function and types of collision resolution techniques. So in closed addressing, we don't have provision to store the data in the next freely available locations. So by using chain of list, we can store the data in closed addressing. In open addressing, we can able to store the next freely available locations with the help of hashing function. Um, but it makes use of an array. So in closed addressing, we have only one technique called separate chaining, and open addressing, we have three techniques called linear probing, quadratic probing, and double S. Now I start with the separate chaining, which makes use of linked list. In separate chaining, each location in a hash table store a pointer to a linked list. That is, if we have array of linked list, no, pointer to a linked list that contains all the key values that were hashed to that location. Chained hash tables with the linked list are widely used due to simplicity of algorithms to insert, delete, and search a key. The starting session of itself, I explained about that is chained list. So, this is an example for that is separate chaining. So we use chained list, that is array of linked lists to implement separate chaining concept. In separate chaining, for example, I may have the hash table. For example, if I consider hash table size is 10 means the memory blocks will be indexed from 0 to 9. These are the array of linked list, and we can map several keys to the memory location. So the output of the hash functions, this hash table will be looking like this. Now, I'm in a position to explain with an example. For example, I wish to insert the keys 7, 24, 80, 52, and 36 in a chained hash table of size 9. If you have a hash table size is 9 means the array of linked lists are indexed from 0 to 8. Totally, we have 9 entries here. Initially, the array of linked lists are set as null. Okay, this is the initial step. Now, I wish to use the hash function, that is division method, which of equal to key modulo hash table size is 9. I use this hash function for my entries. Okay, now initially the array of linked is null. Now I'm in a position to store 7. What happens? Key is 7. Apply 7 modulo 9. You will get 7. In 7th place, just create a new entry 7 and it is set as null. This block will be set as null. Okay. Yeah, now the 7th position does not have null values because I have one entry 7. Okay, just create a linked list for location 7 and store the value only 1. Next, I wish to store 24. 24 modulo 9 will be 6, I think so. 7. Next one is 18. 24 is missing. So, okay. 24, I just apply 24. 24 modulo will have get um, sixth place. I just create a get this will be the knowledge. A similar way we can store 18. Just apply 18 model operation on 18. 18 model on 9, you will get 0. Just create a node and store the data. Okay. In this way, we can store the data by using separate. I think this seems to be easy for you. Next, I wish to store 52. 52 modulo 9 is 7. So in 7th place, I create a new node and attach this 7, which is already inserted. I hope you understood this separate chaining concept. Okay, now I wish to store 36. Just apply modulo function 36 modulo 9. You will get. If the two entries have the same memory location, shares the same memory location, means just to create a node and attach with the previous data. That's all. This is a concept we can separate. Now I'm in a position to tell about the implementation part. So since we have used the array of linked list, first that is you maintain data part and address of next part in the node section. No? So I need to create a data structure like struct node followed by int tr data. You can use whatever name you want. And you have to keep address of next node. Since we are using single linked list structure node star next. So this is the data structures for maintaining the hash table by using separate chain, because we make use of array of linked list. For example, if I wish to maintain an array of linkers, if I wish to maintain a single linked list means just to use pointer. If I wish to maintain array of linked list means here itself you can mention. You can easily mention hash table. For example, my hash table size is, for example, I can mention hash table global variable 10 means the hash table size is 10. Let's mention as yep. That's some. This is array of linked list. So this way we can create a data structure. There is array of linked list. Now I saw the implementation. Here I create, I input header files and mention the hash table size is 10. So, if I wish to use memory allocation, there is MLA function means I use std_block. Here I use C programming language for implementing this. For making use of IO functions, I use std_block. Next, as I told already, I use hash table. I mean linked list for storing the data. So this is the example now here maintaining here. So I have created a data structure which holds the nodes in a linked list. Here I have named as data and address of next. Next, I use array of linked list by using the another data structure called hash, which maintains the number of nodes in a that is each and every entry in a linked list. And I also mentioned maintaining the address of a head node. There is nodes, each and every nodes in a linked list. So here, if I was to maintain the address of a head node, means there is starting address of a linked list means I use star head. Now I create a hash table with null entries just to use as is a new data structure which is maintained, which is used to be maintain the array of linked list. Here I have set all the values null, so which is looking like this. Now, I just implement the insert intelligent searching operation. Here, I use insert operations which accept the element to be inserted and returns nothing. As I said already, first we need to apply hash function on the element to be inserted. You will get some value, that is stored in H. And for storing the new data into the hashed location, I just allocate a memory for new node. With the help of MLR function, we can allocate a memory dynamically. Here, I use size of operator to get a size of a node, and this information is passed into the MLR function, which returns the address of a memory that you allocated. Now, you can set the memory data to be allocated, data to be stored, and next field should be set as null. First, we need to check whether I'm going to insert the element for the first time. If it is the first time, means I just inserting the data just like inserting the element in the beginning position. That is to be checked. Now, his head is null, means just set new node to the head position by using the statement hash table of h equal to head. Here, the hashed values index mentioned here. See here. E mod size is stored in h. That h is mentioned in array of hash table. For example, the h is 5 means in fifth location, I store the data. If h is 5 means. Okay, if h is 0 means in first location, I store the data. Okay. Next, if head is not null, means just attach the data which is already inserted. Okay. So just like inserting that end. If head equal null means just like it's just like an operation that is insertion at begin. If the data is already available, that is head is not equal to null means it is just like inserting the element at end position. Okay. So whenever you insert the data, just may increment the count. How many? That is, you can track. It is not necessary, but you can track how many data that is inserted in each and every uh, node in a each and every linked list in an array of linked list. Okay. And delete search operation, and the same thing. You have to apply hash function on the data to be searched and check if count is not equal to 0. If count is not equal to 0 means you can directly scan the data. If count is equal to 0 means you can say that the element is not available. If count is not equal to 0 means enter into the linked list. Just store the address of a head node into the temporary variable and just search the data by using while loop. Okay, if until you will get null pointer. Okay, if next field is null means it will stop. So it just iterates. Okay, it makes use of loop. In worst case, you will get running time as order of n. Best case, average case, you will get order of 1 for the hash table. So this is a loop. If the temp of data is equal to the element to be searched, you can mention the element is available in the index position. So if it's not equal means just increment the, there is just increment the index value that is high value. And also you can move to the next data. That is, if you have more than one data means, for example, if I wish to set 36 means you start from 18. If it is 18 is not equal to 36 means you just move to next pointer by using the temp equal to temp of next. Okay. Now you can scan the data which is equal to 36 and return the address of this node. Okay. So in this way, we can search the element and deleting entry, same hash function is used, and you just remove the data which is available. Just like in deleting the element to middle person, beginning person, or end person. Okay, now I wish to delete the data. Same thing, you have to find the hashed value. If the hash table count is not equal to min, you can try to search the element. Here, I just store the address of a head node to the temporary variable and using the loop. In best case, average case, the running time will be order of 1. Worst case, running time will be order of n. Okay, because if the data is queued on the same memory location means the running time will be, for example, totally I wish to store 10 elements, consider. Okay, if in 0th position itself 10 elements will be available means that will be the worst case input. Okay, you have long chain in the one position. That is data. It means that data is not equally distributed means you will get running time as high. Okay. So while considering the hash table, you have to make sure that the data is uniformly distributed. If data is uniformly distributed, means that you will get less running time. Otherwise, the running time will be high. At the maximum, it will go to order of n. It is. Now I just iterate by using the loop. If the element to be deleted is equal mean, just uh, just remove this node by storing the address of this node. That is, for example, if I was to delete uh, y means I just store the address of z to the next part of the x. Okay, so by breaking the chain, I'm using this statement as table of h of head equal to h of head of next. Okay, so in this, in a similar way, this is called that is deleting at beginning position. This is called deleting the element at middle position. Okay, so if head is null, the element to be deleted is head position means you will use this statement. If element to be deleted is in middle position, somewhere else means just to use this statement. Temp of next equal to temp of next of next. This is the temp. Consider this is temp. Temp of next is this one. So temp of next is jet. So jet's address is stored here. This is the meaning of this statement. So if after committing the while loop, you are not able to return any value in if condition. To if condition means it will come out of the loop and saying element not available. So this is the implementation of as table. That is by using separate chaining. This is the concept again, separate chaining. Now I wish to tell about how to display the hash table. So this is simple. By using loop, we can scan each and every linked list in an array of linked list by using this is loop. It starts from 0 and ends with size -1. That is hash table size. First, you need to store the head address, and you need to scan each and every node in the linked list by using the while loop and store the data. Okay, and set as null. You will get array of linked list which is looking like this. Okay. Now I'm in a position to tell about other methods called that is close open addressing. That is linear probing, quadratic probing, and double hashing. If you use closed addressing means it makes use of a linked list which consumes more memory. Okay, that is the reason we prefer other method. And while inserting the data or deleting the data, fetching the data, we need to take care of load factor. Load factor should not exceed 0.75. Okay. If load factor can be calculated by using the number of entries in the table and number of that is size of a table. It is load factor. Certainly, it is reference alpha equal to number of entries in the hash table divided by size of a hash table. Some resource says that it should not exceed 0.75. If it exceeds 0.7 means uh, that is hash table going to become full. So we need to rehash the table. That is, you need to increase the table size. Sometimes you may double the hash table size. So while using hash table, you need to identify the hash, that is load factor. Load factor should not exceed 5. Some scientists, research scientists, saying that load factor should be below 0.5. So in open addressing, we use linear probing, quadratic probing, and double hashing. For example, while performing linear probing, quadratic probing, and double hashing, we use hash function like this. So hash function may be defined by using x modulo table size modulo m. And this is this is a function. There is f of I. This is a function which is used in collision resolution strategy. Usually, it start from 0. Okay, if it is a linear probing, means it starts from 0 and it just probe to next pre-available location by incrementing the value by 1, 0, 1, 2, 3. If it is a quadratic probe, means we just probe the sequence. There is f of I should be like this: 0, 1 squared, 2 squared, and 3 squared. If it's a double hashing function, means if the key that is mapped with the memory locations not free, means you use another hash function. Okay. There is a double hashing function. So I explain one by one. First, I start with the linear probing. In linear probing, collisions are resolved by sequentially scanning an array. Okay. So, for example, if I wish to map X to a memory location, if the location is not free, means just store the data in the next freely available location. If next location is not also free, means just try for other location. Okay. So this is the concept behind linear probing. So it is the probe sequence. It is the key is mapped to the memory location is going linearly. That is why it called linear probing. If it is going quadratically, means it will be called as a quadratic probing. If you use two hash function, means it will be called as a double hashing. That's all. So here I just wanted to insert 89, 18, 49, 58, 9 into the empty hash table. I consider hash table size is 10. Here I use division method. Just use h of x equal to x modulo 10. I just sort f of I equal to I. I means it is a linear probing. Okay, if I use I square, it's a quadratic probing. That's all. For example, I start with linear probing. I try to store 89. 89 modulo 10 is 9. So the 9 is 9th location. I store, just map the data. Now 18 is modulo 2 with 10. I will get 8. So in 8th location, I store 18. And the next data is 49. Spot 49 is applied to the hash function. I will get 9. Now 9th location has 89 already. So next freely available location is 49. So just store here. So now this is achieved 49 modulo 10. Initially I set I equal to 0. So I will get according to the function. Already I mentioned this function. This function I apply this. So I will get 9. 9th location already 89. I have 89 now. So I just use f of I as 1 here. Now apply 49 modulo 10 is 9. So you will get 9 modulo 10. 10. So 10 modulo 10, I will get 0. So next field available location is 0. 0th location, 49 will be stored. Okay. For example, I try to insert 59, 58. Now I get 58 modulo 10. The result is 8. In 8th location already I have data, no? I just to probe the sequence. For example, I just apply 8 this result 8 plus in place of 0, I just apply 1. 9 modulo 10, I will get 9. Ninth location, I don't have space now. Just use f of I is 2. I will get 0. 0th location also I have data. So the next, when third attempt, I will get 3 plus 8 modulo 10. You will get 1. The location, one location is free now. I just store 50. In this way, we can store data. So if data that is to be stored in a memory, okay, it's not able to held up in memory. There is the data with the memory location is already full. We try for next freely available location by probing it. Okay. So here I made a 4 attempt. Okay, 4 attempt to store data. The attempt that you made to store the data in a memory is called probing. Okay. If number of probe increases, means the memory, there is a running time complexity will be increased. Okay. So I hope you understood about linear probing. Next, I move on to other concept. So, for example, find for 58 involves 4 probes. Already I told, no. For instance, also I made 4 probes. For find operation, I make 4. For find operation for 19 involves 5 probes. So number of probes gets increased, no. The running time will be very high if you use it. And also if you use the linear probing, means the group of data will be available here. Okay. So the data is not uniformly distributed. If data is uniformly distributed, means it leads to a less running time. Data is not uniformly distributed. It forms a group. That is, it forms a primary cluster. Okay. So it leads to a poor running time. That is why we are going for another method called quadratic probing. So, for example, if I wish to perform insertion operation on uh, hash table by using linear probing, means I just define insert function by having x as a element to be inserted, and I just map the key to the hash table by using division method x table size. If x table size is equal to, initially it's set as 0, empty, that is empty table will be considered 0. If table is empty, means just correctly store the data. If table is not empty, means it means that it's collision. If it is collided, means just try to probe by incrementing the value by 1. So this is the example for linear probe. If number of probe is equal to the table size, means that there is no memory is found to store the data in a hash table. So in this way, we can perform insertion operation. In a similar way, we can do search operation. Search operation also, if just to use hash table, there is a hash function. Just apply hash function here. H of x modulo table is equal to x, means the element is found. If element is not found, means just try to check next freely available location. If number of attempt is equal to 10, means just equal to table size, means just tell that the element is not found. Okay. In a similar way, if you wish to delete the elements, you can just use same hash function. If cost of x remainder table size equal to x, means just set as 0, just reset the value. Sometimes in place of 0, I may use -1, or you can use lowest values, negative value. Okay. You try to probe if key is not mapped with the value. Try to probe. If number of probe is equal to size of a table, means it means that the element to be deleted is not available in the first table. Okay, if you wish to delete the hash table, all the hash table entry means just make all the array values to 0, just like by using for loop. Very simple. Just apply for equal to 0. It is an table size I plus plus. Just mention of I equal to. This is the way of deleting the hash table entries. Okay. Next, I wish to tell about quadratic probing. I told about drawbacks of linear probing. There is number of probe sequences gets increased. Quadratic probing involves the function f of I equal to I square. In place of I just use I square. So just simple, it is just simple. Just while implementing quadratic probing, in place of I plus 1, just use I square. That's very simple. Just use I square. While deleting also, while searching also, just use I square. That's all. This is the concept behind quadratic probing. In quadratic probing, the data is maybe uniformly distributed. Sometimes it form a cluster, small amount of cluster. That cluster will be considered as a that is secondary cluster. Okay. Now I just explained with an example. Here I use hash functions for storing the data into the hash table. First, I just apply 89 modulo 10. I will get the data that is stored in the 9th location. And now apply hash function on 18. I will store 18 smoothly. Now I just apply 49 modulo 10. I will get the 9. 9th place already I have data now. So I just probe by using the 9. I just apply f of I, f of I, just 1 square. I will get 10 modulo 10, 0. So 0 partner will be stored. Now in 58, for 58 modulo 10, you will get 8. No? In 8th location, I have data. No? It's not possible. So I just apply 1 square, 8, modulo 10. I will get 9. 9th location also. I will have data. So I try to prove again. I will here now in place of 2, I just use 2 square. So modulo 10. I will get 8 plus 4, 12, 12 modulo 10. So if you use linear probing means data will be stored here. It form a group. If you use quadratic probing means data will be stored in the third location. So in this way we can store the data. If it is not possible to store in the second location, just try to probe by using 3 square like that. So the power has to know. That is why it is called quadratic probing. So in quadratic probing, number of probe may be reduced, but it forms a secondary clustering. Okay, in fact, it forms a secondary. So we use other method called double asking. If you use double asking, we may assume that the data will be scattered or the data will be uniformly distributed. So that double asking involves second hash function, which is used to derive the coefficient expression. The second hash function is called f of I equal to I into hash suffix to x. So if the data is not able to stored in the memory location, it just use this hash. So here I just use hash function equal to r minus x mod r. So for example, I wish to store the data by using double S function. For example, 89 modulo 10, you will get 9 and store the data. And 18 modulo 10, I just store 8th location. It's very easy. And 49 module 10, the collision arises. In this situation, what you do is in place, I have to use that is this function now. Now I consists 0. If I consists 0 means I may get there is 0 only. So when I gets 1 means 1 into here I apply has function, has to function. In has to function, I have to choose R. So if has table size is M means you have to choose the largest prime number which is less than M. Here my has table size is 10. So the largest has prime number which is less than 10 is 7. I choose 7. 7 R is 7 minus value that is to be stored is I think 14. So I just choose 49. 49 modulo 7. So I will get f of I equal to like this. So now 7. 49 modulo 7 is 0. Okay. So value is 7. You will get value is 7. No? Now go here. Here already 49 modulo 10. I will get 9. No? 9th location is not possible. No? 9 plus 7 modulo. Okay. What will get 6? Sixth location that I will be stored. Actually 49. If you use linear probing means 0th location will be stored. If you use double asking means, quadric probing means the data will be stored in the same location. If you use double asking means the data will be stored in the 6th location. This location data will 49 will be stored. Okay. So data is, we can have a assumption the data stored in the distributed way. Data is uniformly distributed. We use double asking. Okay, so number of probe sequence also will get reduced. This is the concept behind double asking. So here I wish to compare the efficiency of collision resolution method. Consider the x-axis load factor and y-axis average number of probe. If you use search operations for these techniques, separate chaining, there is average number of probe is very low if you use separate chain. If you use double asking quadratic probing means average there is average number of probes. There is number of attempts will be reduced when compared to the linear probe. So in linear, if you use linear probing means the average number of probes will get increased exponentially. Ancestral search separation is also better, but it consumes more memory. That is a drawback. But the number of probes will get increased if you use linear probing. Okay. The application of hashing, I wish to tell, it may be used in online spelling checkers, and many game programs uses hash tables to keep track of positions it has an number. Actually, game programs usually use transposition table to keep track of the positions of an object. And compilers use a hash tables to implement the symbol table. Symbol table contains the tokens. No? So symbol table entries are stored by using the hash table. So you use variables that is to be used to that is compute the operations. Some operations are tasked. No? For the purpose, we use hash table. So here I have given some introductory aspects of a hashing function and types of hash function, and then I have moved on to way to reduce, resolve the collision risk. Collision, if you try to store the data in hash table, basically I have explained there is open addressing and closed addressing, which makes use of array and linked list respectively. Finally, I have end up with hashing applications. So with this, I stop this session. If you have any queries, you can raise. Thanks for the opportunity to present this session.
Thank you so much for the session, sir.
Thank you.
Professors, if you have any doubts, you can ask Kannimuthu, sir. Sir, I hope they don't have any doubts, sir. Thank you so much for joining the session, sir. Thank you, sir.
Thank you, ma. Shall I leave this session?
Yes, sir, you can leave, sir.